All right, let's just dive right in and crack the code on Cambridge AS and A-Level Mathematics 97.9. Specifically, we're zeroing in on Section 4.1, Forces in Equilibrium, with a real laser focus on Newton's third law. Now, we all know this is an area where, quite frankly, a lot of students just end up leaving easy marks on the table. But today, we're pulling back the curtain. We're looking directly at the data from principal examiner reports to see exactly what they actually want from you. By the time we're done, we're going to completely transform how you tackle these problems so you capture every single mark you deserve.
So, here is our roadmap for today. It's essentially a sneak peek straight into the minds of senior examiners, taking us from Section 1's core principles of equilibrium through the procedural framework, formatting, critical analysis, and finishing up with the ultimate examiner warnings.
Let's kick things off with Section 1, Core Principles of Equilibrium.
Now, this is a critical question straight from the senior examiners themselves. Why is evaluating evidence and actually drawing solid mathematical conclusions such a massive stumbling block for so many? Well, the examiner reports highlight a really fundamental gap in how students approach the exam. Too many candidates are aiming for superficial breadth, just trying to write down every single formula they've ever memorized. But the academic benchmarks explicitly prioritize analytical depth over that kind of scattergun approach. The examiners don't just want a list of physics and math facts, they absolutely need to see logical, structured reasoning.
And what's really fascinating here is the emphasis on integration. Yes, the theoretical architecture of Section 4.1 rests heavily on precise definitions and causal relationships, but it definitely doesn't exist in a vacuum. The principal examiner reports explicitly point out that candidates who reference cross-topic connections achieve significantly higher marks. It's like a giant puzzle. If you can show exactly how Newton's third law interacts with other areas of the syllabus, demonstrating a really holistic understanding of forces, you immediately elevate your response from just average to genuinely outstanding.
To actually satisfy those benchmarks, you have to hit 3 distinct cognitive domains. Listen, it is not enough to just have the basic knowledge and understanding of what Newton's third law is. You've got to demonstrate application, actually using the law in whatever physical scenario they throw at you. And most importantly, analysis. You need to systematically analyze the evidence-based reasoning behind how these forces interact. Hitting all 3 of these is absolutely crucial to proving that your reasoning is totally airtight.
Moving right along, we reach Section 2, the procedural framework.
Because honestly, having all that brilliant theory locked in your head is completely useless if you don't have a systematic, reliable way to get it onto the paper under extreme exam pressure. Whenever you tackle a forces in equilibrium question, you absolutely must follow this standardized 5-step sequence. You start by identifying the key elements and deconstructing the question, then you apply the relevant principles, execute your analysis with totally clear working, verify your results, and finally, present it in the appropriate format. Skipping even one of these steps, that's exactly where candidates start to derail their own logical flow.
And that brings us to a real game changer, the method mark strategy. This is huge, guys. Examiners heavily reward the process itself. You've got to execute your steps with clear notation and correct terminology, because marks are rewarded for your analytical journey, not just for magically arriving at the correct final number. Think about it. If you make some tiny arithmetic error right at the very end, but your method, your notation, and your systematic processing are absolutely flawless, you're still capturing the vast majority of those marks.
Which brings us naturally to Section 3, Formatting for Top Marks.
Look, presenting your information in this section follows some really strict conventions. We're talking about using proper headings, correct formal terminology instead of just casual phrasing, appropriate formats for your working, and crystal clear annotations on all your force diagrams. The examiner reports are painfully clear about this. Failing to stick to these standardized conventions literally means throwing easy marks out the window. Your brilliant mathematical analysis just gets completely lost if the examiner can't easily follow your annotations.
Okay, let's jump into Section 4, Critical and Comparative Analysis.
This is the phase where top-scoring candidates truly separate themselves from the rest of the pack. When it comes to comparative analysis, the demands are pretty rigorous. You can't just list things. You must identify both similarities and differences. You've got to explicitly use comparative connectives to link your thoughts. You need to support every single comparison with hard evidence from the data. And finally, actually draw conclusions about the relative importance. Top candidates are constantly questioning assumptions, considering different angles, and justifying every single decision they make. And there is a massive conceptual difference between a generic answer and a context-specific one. A generic answer, it just regurgitates a textbook definition of Newton's third law. And guess what? It loses marks. A top-tier response takes that deep theoretical knowledge and links it perfectly to the specific, unique scenario given in that exact exam question. Context is absolutely everything when you want to demonstrate true analytical depth.
Let's move to our final section, Section 5, Ultimate Examiner Warnings.
We've extracted the most vital warnings directly from the principal examiner reports, so you don't fall into the same traps past students have. If you want to protect those precious method marks, avoid these 3 classic mistakes. Number 1, using the wrong approach for the wrong context, like trying to force a formula where the physical constraints just don't allow it. Number 2, forgetting to check your format and presentation, which we already know bleeds method marks. And number 3, providing answers that are entirely divorced from the specific context of the question. Just look at this quote straight from the examiner alerts. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. This is literally your ultimate takeaway today. If your reasoning isn't anchored securely to the contextual evidence of the problem right in front of you, you are simply not scoring top marks. Period. Every analytical point, every single force diagram, every equation, link it back to the scenario.
So I'm going to leave you with a question to ponder the next time you sit down to study. You now know exactly which cognitive domains they're testing, you know how the method mark strategy works, and you know the exact pitfalls the examiners are actively warning you about. So, how are you going to restructure your very next past paper practice to guarantee you capture every single method mark you deserve? Think about it, apply this playbook, and keep that structured reasoning front and center. Good luck out there.